So we're going to have to go back to 4.8. And we're going to talk about headings and bearings. And again, headings and bearings is just a way of telling direction. Okay? We'll start off with the definition of what a heading is. Okay, so a heading is a way of giving an object's direction. So it's a way of giving an object's direction by using angles. Headings always begin measuring from the north. Okay? There's an actual definition, but that's as simple as I can put it into everyday words. Okay? I'm going to show you graphically what I mean by that. Okay? Let's pretend we have a compass. So in case you've never used a compass, I'm not going to actually draw a circle, but technically this is the north. Hopefully you know that that's the south. And to your right is going to be your east, and to your left is going to be your west. If you've never used a compass before, some people like to use some kind of acronym. Somebody told me in first period that they memorized it by saying never eat soggy waffles. I don't know. Or never eat sour worms, I think someone said in first period. Whatever. However you want to memorize it. If you've never used a compass before that, there it is. Hopefully you have. It says that it is a way of giving a direction using angles, but angles always begin measuring from the north. So what that means is that the north is considered 0 degrees. Okay? And you measure clockwise. Okay? Which means that you have to go on this direction. And I want to make sure to take a moment to really explain that you have to be careful, because we've been talking about the unit circle for a long time. And the unit circle is not here. Agreed? With the unit circle, 0 degrees would be located where? Where your east is located right now, right? But the unit circle has nothing to do with direction, guys, okay? This is a compass. So to ensure that I know what you're talking about when I'm reading your paper, you need to have this labeled. I need to know that you're talking about a compass. Because if you don't have north, south, east, and west, I don't know what you're talking about, okay? Now, we're going to start with something simple, which is sketching a situation. Can you come up with a diagram, okay? So I want you to sketch the diagram. And here's the situation, okay? So I'm just going to make something up. Parker is heading, okay? So he's heading at 137 degrees, okay? He's riding his bike at, I don't know, 15 miles per hour. And he rides his bike for 3.5 hours. Where is he located? I need a sketch of this. So I'm going to explain to you how you would go about this, okay? So Parker's heading on 137 degrees at 15 miles per hour for 3.5 hours, okay? So if you want to draw a diagram of this, so first you need a compass. Cool? If you ever use a compass, then this is you, right? So like you're standing and this is you, and then you just got to follow the arrows. There's an arrow that tells you where the north is, etc., right? So once you figure out where the north is, right, Parker's going to head 137 degrees from the north. So if this is the north, right, 137 degrees, remember how the definition of a heading says that you have to go clockwise, so that's 90 180, too far, right? So it's got to be somewhere in here, right? Now, I don't expect you to give me this exact sketch, so I'm just going to say it's somewhere here, right? But you're going to have to label your angle so that I know what you're talking about, right? I don't want you to put 137 degrees. I need you to give me the measure of this angle, which would be what? Cool. All right, so here's what I can tell from your diagram without this information. I know that there's an object that's traveling at 137 heading, but that's all I know. There was more information to it. Parker was going 50 miles per hour for 3.5 hours. So you know how far he went. Agreed? How far did he get? Well, 15 times 3 is 45. And half of 15 is, so then he traveled how long? I mean, how far? 50 what? 52.5 miles. And that's what I will be expecting. This lets me know that there's some object or something travel and a heading of 137 degrees for 52.5 miles. Cool? All right, that's simple. Now you draw your own sketch. Here we go. I don't know, something is heading at 258 degrees at 100 miles per hour. Well, kilometers, how about that? Kilometers per hour for 5.75 hours. So there's some object that's heading on 258 degrees at 100 kilometers per hour for 5.75 hours. 75 hours. Draw a diagram of this. Okay? So if you're watching the video, please pause and try this on your own. Bunch. Alright, if you're watching the video, please check your answer. Alright, so you're heading on 258 degrees, so you should be located down here, right? The angle here should be 78. And if you are traveling 100 kilometers per hour for 5.75 hours, it should be 575 kilometers. Agreed? Yes, what's up?
Do you need to do 78 instead of...
It doesn't matter. I'm okay with it. Okay? You could do 12 if you wanted to right here. That has to do with bearings. We'll talk about bearings here in just a second. Okay? But I'm okay. At the end of the day, what's going to happen is, right now we're just sketching, but you're going to use sketches to solve problems. So some problems you're going to need to know both angles, okay? So if you can identify that this is 12 or that's 78, I'm totally okay with it, right? Together they should make the 90 degrees, correct? Are we good with that? Alright, headings. Are we cool with headings before we move on to bearings? Alright, so then let's talk about bearings. Alright, bearings are probably what you're more used to, but bearings are used to give an object's direction by measuring an acute angle using the north or the south as a starting position. Well, I wouldn't say position. Let's say as a starting... How can I phrase this? Let me explain the drawing and maybe we can come up with a word. Okay? Alright, so write down the definition. What's that? What is that? I don't know if we would say reference angle. I'm just trying to come up with an easy explanation for you. So let me kind of like show you what I mean and then maybe we can come up with a better word. Okay? So here's what this definition means. You're still going to have a compass. So here's your north, south, west, and east. What it means is that when you have a bearing, you're going to have to begin measuring from either the north or the south, which means that the north and the south are both considered 0 degrees. Okay? And then you have to measure going on this direction. If you go in that direction, that is considered going northeast. But if you go in this direction, that is considered going northwest. Southeast, southwest. Does that kind of explain what I mean by using the north and south as a starting? I don't know. The wording bothers me, but if you're watching the video, I hope you understand what I mean. Like, you're starting here, this is the 0 degrees, and then you go either towards the east or the west. Same thing with the north. Are we okay with that? Okay. Well, the thing is, like, what's going to be confusing is that some people are going to take it very literal, saying that this is where you're located. But you're not located there. You're always going to be located at the origin. You see what I'm saying? So if I say starting position, I'm afraid someone's going to get confused with that. For measuring the angle. How about that? Starting position for measuring the angle. I don't know. I hope you understand what I'm trying to say. Okay? Alright. This doesn't change much of what we've been doing. I want to do the same exact situation. So I want you to sketch a diagram. Someone's going on a bearing of 58 degrees. And the way you watch it, the way I write things. So 58 degrees southeast. It's just the way that it's written, okay? The way you read this is 58 degrees southeast, okay? And let's pretend that someone is going 60 miles per hour for 2 hours. Sketch. 58 degrees southeast. So give me a sketch of that. So here's the north, the south, the west, and the east. Alright. I like the way this is written because that allows me to know where I need to begin. The S tells me that I should be in the south first, and I need to go 58 degrees towards the east. So that means I need to go in this direction, and then I'm going to have a line going like this. Okay? Which means that this angle right here measures how much? 58 degrees. And how far did I get? How much? 60 miles per hour at 2 hours? Okay. Cool? Do you understand the difference between a heading and a bearing? Alright, so a heading, just to kind of summarize, a heading always begins the measuring of the angle from the north and goes clockwise. And a bearing will either begin at the north and south and then go on either west or east direction. Okay? Yes, sir.
So if it's just like a problem, no word problems with someone has a heading or bearing, it's just we can tell the difference just by how it's written.
Exactly. You can tell the difference exactly by the way that it's written. So, if you just see something like just an angle, you need to know that that's a heading and that you need to start at the north. I like bearings because they tell you exactly what to do. Okay? Are we good? Alright, so that was just prep for now, finally pre-cal. Ready? Let's do this. Well, as you know, and if you've traveled before, either by plane or on a boat, I don't know, most of the time, it is actually very unusual for just the plane to take a straight path. Sometimes it is possible where they go, like, let's say from Dallas to Florida in a straight path, right? But sometimes it's not that simple. There's more variables to it which we're not going to talk about in this class, but not always can a flight take a straight path. Sometimes they have to go in certain direction and then switch directions and make it to wherever their final destination is. So in other words, we're going to have situations where you're going to have to change direction as you're going. Now, to keep it simple for this class, we're only going to change direction once. Not twice, I'm sorry, once. Okay? So here's what's going to happen. First, I just want you to sketch the situation. Okay? We have, let me come up with one. I don't want to write the word problem, so here we go. You have an airplane that is flying for 500 miles at 60 degrees. 500 miles at 60 degrees. This plane is flying, and during the flight there was a storm, and then they have to change directions to avoid the storm. Okay? So it flies at 500 miles, and then he has to change directions, and he flies another 200 miles at 150 degrees. I want you to sketch the position of the airplane after once basically here, after the 200 miles. Where is it located? Okay? From there, we're going to do more with it. So first, let's see if we can come up with the sketch. Any thoughts of what I need to do first?
Find the 60-degree angle.
First, let's start at the beginning. Like, you have to. Here's my airplane. Let's pretend that's the airport, right? It has to be at the airport, right? Okay. Here's my compass. I like to always draw my compass. And I typically like to use dotted lines. You don't have to, but here we go. Here's the airport. Where do I have to go? 60 degrees. Is this a heading or a bearing? Heading, so I need to start where? North, and go clockwise. So in this direction, so maybe somewhere here. And I'm going in that direction, and for how long or how much did I travel? So this is 500. So I'm going to make this a little longer. Then what's going to happen?
You can create a new compass at the end of the 500.
Exactly. At this point, you're going to have to create a new compass, guys. But the compass should look exactly the same. The north should still be in the north. Like, that's not going to change, right? Here's your south. Here's your west, and here's your east. Based now on your position, what do you have to do? Go 150 on a heading of 150. So starting from the north, that's 90, that's 180, so it's right before that, so maybe here. Right? How far did you get? 200 miles. Okay? Now, just to make your life easier, we forgot to put the angles where they belong. Just a reminder, this was how much right here? 60. And how much would this be here, guys? 60? Do you guys agree that it will be 60? Because this is 150, and then this is just 90, so 150 minus 90 is 60. Alright, you guys with me? Alright, if the question was to draw the sketch, you would be done. But the question is not going to be to draw the sketch. You guys ready? Here's the question that I have for you, and I want you to think about it for a moment before I actually explain it to you. I want to know, what is the distance from the airport to where my airplane is located at this moment? So in other words, I need to know what this is, so let's call it X. We need to find X. Now, I heard someone say that we could use Pythagorean theorem. Now, here's the thing. What do I need to make sure in order for me to use Pythagorean theorem? That I have a right triangle. Hopefully you recognize that I have a triangle. At least that. But if it is a 90-degree angle, then bingo, let's use Pythagorean theorem, right? So let's try to see if it is a 90-degree angle. So I need to figure out if this is 90 degrees. And I have enough information for me to determine if it is or not. Okay? Any thoughts? Okay. So Aniket says that this right here, and it's kind of small, so let me zoom in. Do you guys notice how here I would have 90 degrees, right? So if this is 60, then this small angle right here has to be 30 degrees. You guys with me? All right. Questions about why that's 30? Now, I need to figure out, let me change colors, what this is right here in the red. If it's 60, then it's going to add up to 90, and then we're going to be able to use Pythagorean theorem, right? But if it's not 60, we're not going to be able to use Pythagorean theorem. Agreed? All right, how can we determine if that's 60? Geometry, guys. Look. I'm going to zoom out a little bit. No, actually, you can see it from there. Do you guys see how this is north-south? Right? This is still north-south, which means that this line right here and this line have what relationship? They're parallel. So this line and this line are parallel, and then you have a transversal cutting through it, and you know that alternate interior angles are, so that means that this angle right here is 60 degrees. Therefore, now you know that you have a 90-degree angle, which means that you have a right triangle, which means that you can use Pythagorean theorem to figure out x. So, find out what the distance is from the airport to where the plane is located. So, x equals to the square root of 500 square plus 200 square. Do you guys understand why I'm taking the square root here, right? I'm just skipping a few steps. A squared plus B squared equals C squared, right? Okay. So, go ahead and plug it in. Try it on your calculator and somebody tell me what you get. 538, and let's use 3 decimals. 516. And what's your measurement? Miles. Cool? Alright. We're going to continue with this diagram. I have more questions about this diagram. Okay. I want to know now if, let's pretend for a moment, from the airport, instead of going this direction 500 and this direction 200, if instead I could have just gone straight to this position, what would have been my heading? That's what I want to know. So, any thoughts?
The bottom line?
Yes, so let's pretend that from the beginning you were here in the airport, but you never went on this direction. You went just straight to here, using this line right here. I want to know what the heading would be from the airport. What's that? What do you mean?
The angles, so if it's a bigger angle, that means the opposite side is the bigger side.
Oh, I see what you're saying. Like, so you're going back to geometry a little bit.
90, because you have 90 degrees left over.
Right, so based on that, let me kind of refresh your memory on what he's trying to say here in case you don't remember this from geometry. But the biggest angle here is 90 degrees, right? So that means that this opposite side is the biggest side, and it makes sense, right? We already found out that it was bigger, right? Which means that this is 200, which means that opposite from it needs to be the smallest angle, and then opposite of the 500 needs to be the medium-sized angle of the triangle. Do you guys remember that? Okay. But what about that, Parker? Like, what can we do with that?
You do a ratio of 90 degrees to 700 miles.
Try it and tell me what you get, okay? I have never thought about that. So hold on. So you try that and then we'll get back to you. There's something else we can do here though. Well, we have a triangle. We have a specific type of triangle, right? But we still haven't really determined what I'm looking for. I know that I'm looking for the heading, right? But I'm looking for an angle. Agreed? What angle am I looking for? I'm looking for technically this angle right here. Do you guys agree? We'll see if that's what we get, okay? So, we're looking for this angle. Do you guys agree? Because if we know that angle, all we got to do is add 60 and then I know the heading. Do you guys with me? So, you have a right triangle. You have the opposite. You have the adjacent. You're looking for an angle. You need to use what, Aniket? Inverses. To find an angle, you use inverses. If you have the opposite and you have the adjacent, what could you use? Theta is equal to the inverse tangent of what over what? 200 over 500. Type that in your calculator. Make sure that you are in degrees, please. And tell me what the angle is. 21.801 degrees. Okay? Now, is that your answer?
No, I got 25.7.
No, I'm sorry. All right. But then, is that your final answer right here, guys? What is the heading then? The heading was 81.801. That's the heading from the airport to the current position right here. Okay? Questions? How do we feel about this so far? Okay. Yes, ma'am. X, because I just kind of started asking questions. So let's say that was part B. Part B was like, what was the distance? So we found the distance. Now, here's my question to you. Did we have to use inverse tangent?
No.
Could we have used like inverse sine instead? But if you use inverse sine, you were going to have to use what? The 200 over the 538, right? Could you have used cosine? Secant. In my opinion, use what's easiest, which in this case was this 200 and the 500 because they're nice whole numbers, right? Okay. One last problem and we're done. We're good? Alright, here's a problem. Write it down because I'm kind of lazy. Oh no, I dropped water on it. Alright, I think you can still read it, maybe. That is water. No, I fell asleep and I drooled all over my paper. No, I'm just joking. Okay, it's water. Alright. If you can't see it, I'll read it. A ship leaves a port at noon and it heads west at 20 knots. 20 knots is just a unit of measurement, okay? It's nautical miles per hour. At 2 p.m., the ship changed directions to 54 degrees northwest. I want you to find the ship's bearing and the distance from the port at 3 p.m. So write the problem down and we're going to tackle this together. And I'm sorry if you're watching the video, but you're just going to have to see the answer because we're going to do this on the board. And this problem, you are solving it, not me. So with your help, we're going to solve it on the board with everyone's help. Understood? Okay? So if you're watching the video, maybe I'll be nice enough to actually make a video during my conference about this problem. If not, sorry about your bad luck. Check the answer. That's all I got for you today.